what I've been using, it's basically Okteto, and I don't know if everyone is aware of it, but this is going to be really fast, and I want to spend some time during the demo and maybe questions after. So basically, the idea that Okteto is having is basically like you have your laptop, right, with your code locally, but then, for example, in our case specific, we have this like the control plane, right, where we have this AWS operator pod, which has the config and secrets and everything else that needs to be in place for this operator to run. You can also do the same with any other operator in the end, right? And the thing that when you do use Okteto, the thing that's going to happen is basically there's going to be like an additional container inside the control plane and a service in your local machine, which is called syncing, that is going to synchronize your code. So basically what it's going to do, it's going to create a persistent volume inside the control plane and modify this deployment. And it's going to synchronize the code that you have on your laptop to the code that it's inside the control plane. So basically, it's going to replace the AWS operator deployment with something completely different, which is basically a like basic Go image with nothing on it, and then it's going to upload our code in there while maintaining the any other persistent volumes, config map environments that were already present in the deployment before, right? So this is what's really happening when you do Okteto app, which means that then you can modify this operator in your laptop, and it's going to upload this code directly to the control plane, right? So this is where you are going to be, like you are going to be editing with either Vim, VS Code, whatever you prefer on your laptop, right? And then also you're going to see that here with these arrows, what I want to show you is that we will have also an SSH into this pod, right? You can also do that via the standard Kubernetes API, which I think is what they are really doing in there. And also you can do port forwarding from this pod into your laptop, which means that in the end, you will have the code here. Then what I use to run the operator is the Delph Go debugger, let's say, right? So you start the AWS operator daemon with Delph, and then you forward the debugging port to your laptop, right? And in this laptop, once you are in your laptop, you can just use the remote debugger of, for example, VS Code on port 2345 or whatever you specify in Delph. And then once this is done, you will be able to debug with the code that you have here in your laptop. And you're going to be compiling and executing everything from inside the same control plane, right? This is one way of doing it. And I think this is the thing that works the best, right? And before I tried to do something different, which was basically the same setup, right? But instead of running VS Code locally, you can also run VS Code inside the same pod here, inside the same AWS operator. And then you just port forward the VS Code server pod, right? And you just connect to this 8080 port, and you have this VS Code, full VS Code running inside the control plane, where you can basically run go build, execute locally, debug locally, whatever you want to do there. And now, if you want to look, we can have like a small demo here. This is, first of all, the only thing that you will need is the Okteto binary, right? And also you will need to prepare some files in here, which is just this octeto.yaml, which is going to configure a few things in there. The most important one are these labels, because whenever you do Okteto app as we said, we're going to replace an existing deployment inside the cluster. So these are the labels that are being used in order to select which deployment we want to modify, let's say, right? Then we can also choose the image that we are going to use. Because, for example, in this case, we are going to use Golang, so we can compile inside the cluster itself. If you want to use a different image, it's also possible. But this one, the Okteto one, comes with this Go, and it's a little bit, let's say, specific for this use case. Also, you can set the command that you want to run on the shell. If you want to have like a full shell or you want to execute any command, you can already do that from here. Other things that we have, it's the port forwarding. This will set up all the ports that we want to forward locally. In this case, what I have is the Delve port, then also the AWS operator port, and 6060 I used last week for for profiling, basically. Another thing is the volumes part. As I told you, it's going to create a persistent volume where there's going to be two different things in there, which is going to be the AWS operator code stored inside the persistent volume. But also another useful thing is that we can also mount the Go build cache, so we don't need to download the dependencies every time, right? Because in the end, what you can do when you disable, let's say when you turn off all the things that Okteto has done, if you keep the persistent volume the next time, then you will have the Go build cache in there already, which can be useful or maybe not. That depends on what you actually prefer. And also you can configure a little bit things like the security context and the resources that this new pod is going to have in there. Okay. So for example, we could Obsidian. I'm going to just deploy the AWS operator master branch on Gauss. And then we're just going to modify this, basically start this operator with Okteto in here. The other thing that I have here, the other custom file, I would say, is basically this debug server, which is the command that I will use to start the AWS operator, which in our case, I had to use this command also, the ignition symlink, because this is something that we do in the pod itself. But then the command that we really use is this delve debug headless, which basically until here, this can be shared between all the different operators. And then from this point onwards, this is just the AWS operator parameters, right? Which you can already, the thing is that I took these ones from the Helm deployment. If you go into the Helm deployment, these are basically the parameters that I'm using to start the server. Another thing that we need to do is you have some documentation here in the AWS operator, and it's going to guide you through this process. And is that in order to use a persistent volume on the AWS operator, we need to modify the PSP, right? So I have this kubectl patch that is going to basically allow running as root and also mounting the persistent volume and entities. And then once you finish that, you need to remember also to revert these changes. But my recommendation is to just delete the whole deployment of this application because we don't want to have leftovers in there. Let's see if this comes up. Maybe there is some issue on Gauss.
How?
Yeah.
When does Okteto builds your code? Whenever you run Okteto app, or is that automatic somehow?
No, the thing is that you need to think of Okteto just as enabling this communication, right, between the cluster,
Okay.
the laptop, and your control plane, right? And once you have this set up, right, the only thing is that you have a shell in there. And then in here, you can either run go build and execute the operator yourself, right? The other thing is once you start this, let me show this Delph debug, right? This is going to build the operator. This is just going to run go build and then execute with these remote debugging capabilities. So maybe let's do one thing. Mm, I want to check maybe we're just going to modify an existing operator in here. So for example, we are going to modify the 931. So the only thing that we need to do here is going to be okay, so this is in the Okteto YAML. We need to specify this 931, okay? And now once I'm in the context of Gauss, and I want to show you exactly what's going to happen here. You're going to see that once I do this Okteto app, right, you're going to see that this pod is being restarted right now, and you're going to see that it's going, well, we don't have the PSP, so we need to modify it. The 931.
It's probably 9-3.
Okay. Yeah, it's 939.
Yes. Yes.
Just like that. Cool. Then we try again. So let me we are deactivating and activating again. You can see that once we deactivate, right, it's going to revert back to the old deployment. And even though I think that it works pretty well without actually doing strange things, it's better to redeploy the whole thing again, just in case. So now, if we look at this pod, right, which is, or at this deployment, you're going to see that we have basically replaced all the containers, right? Here we have this Okteto namespace, Okteto name, CPU that we have set in there. And also you're going to see that we have this init container that has basically the Okteto binaries. Well, it's doing like lots of things in here, right? One thing that we can see here now is that it's synchronizing all the files that we have locally inside the pod, right? So if we check at the pod right now, we're going to see that sync thing now is basically synchronizing all these files. The first time it takes a while, but there is, if you look at here, we have this stignore, which means that, for example, you can ignore some of the files locally that you don't want to put up in there, like for example, the helm term, we don't need it, and maybe there is additional files that we don't need in here, because in the end, this sync thing is going to keep in sync the whole folder. So if we, for example, synchronize the whole Git directory, it's going to get quite crazy. And this is only lasting the first time because it's populating the persistent volume. The next time that we do this, it's going to be really fast because the volume is already there and it's just going to synchronize the differences, right? So now this is done, right? We have the forwarding of the ports already here, and you can see that we have this cell in here. So when I do ls, basically, if you think like it, it's like you are in the same folder as your laptop, but actually inside the same cluster, right? So in here, for example, I could just start doing go build and executing the operator, whatever we want to do. So for example, if I go into the deployment and I do well in here, let me take it from here. And in this, did this actually finish? No space left on device. What? Do we need a bigger volume, maybe? Are we actually using 2 gigabytes here? Let me deactivate and try it again. I think we might have been using like an old volume in there. So basically when you do this Okteto down, right? And with the -v, it's going to delete, it's going to revert the changes on the deployment, but it's also going to delete the persistent volume. So now we are just doing this process again of modifying the deployment. And then we should get it going here. While we are doing that, I'm going to show you also in VS Code, in case you want to use this for debugging, you have this, when you go into debugging, you have this configuration, launch targets, what they say, right? And in this case, what we need to configure for Go, it's the Go type, then the mode is remote, right? And we are going to be using the port 2345, which is the one that Delph is using by default, right? We also need to basically match the remote folder with the folder that we are in. And this is why we are using this workdir/Okteto here. And then we basically map this remote Okteto path to our local path here. Because I think I was too fast in there.
Do you use the debugger a lot? I normally don't use it. I'm not. I don't have the habit of using it.
The thing is that sometimes, like, I've been using it lately because I was modifying the IP address management algorithm, let's say, and it's sometimes a bit hard to know why it's doing something, right? I think that the unit tests are still the best way of doing things, but sometimes when you want to modify something, like this cycle of basically pushing the code, waiting for SQL CI, deploying and everything, that's like super slow. And this way with the remote debugger, if you want to basically look at data structures or something, it's really useful. But otherwise you can just like, maybe if you don't even want to debug, right? But then if you configure everything like this with the Delph, right? Whenever you hit this start debugging, this is going to do the go build for you, right? So anytime you restart the debug, it's going to do go build on the fly. So it's like also like a hot reloading mechanism. So instead of having to stop running go build and executing the operator, just with this restarting from here, it's going to be enough for building everything, let's say. So if anybody has some questions, I don't know, Ball, if this is the like the same setup that you're using. You may be not using like the debugger, right?
Yeah, I'm just building a binary locally and sync binary.
Okay.
So my go-to debugger is fmt print. So I don't need such.
Yeah, but in the end, when you do Okteto up, it's also synchronizing the whole code, right?
No, it synchronize binary. I build binary locally.
Oh, well, okay. Yeah, I mean, in the end, this is going to synchronize everything that you have here. So if you build a binary locally, it's also going to be pushed remotely.
Yeah.
Is that just asking Vol real quick? Is that faster? Like, because you could just exclude everything, right, and only include the binary.
I'm including only binary, sure.
Okay. Is that faster? Because like I can imagine that if you just want to check if something's working and you don't need any debugger, it would be faster to just build the binary locally and just push it.
I think the way POW is using is faster in
Okay.
a long long journey.
I
Because
agree.
if you need to rebuild it often, then it will be faster.
Yeah.
But yeah, I usually just put like tons of prints, build it, and then push the deployment, and that's it.
There is also a third way. What I did last spring, I modified the Azure operator a little bit, and with the modifications, it's able to pick up the local kube config, and I'm just running it on my local workstation against the remote API. So it's kind of effectively the same as running in the cluster, but it's just using the local kube config and running on my machine.
How did you solve the secrets and config maps problem?
But they are in the Kubernetes.
But they are mounted.
Oh, the mounted ones, they are files in my local machine.
Yeah, that's exactly what I do. I have a bash script from the 80s that simply connects to the Kubernetes, downloads the config maps and secrets, puts in my machine, and starts Azure operator. I mean, compared to POW solution, this is like hammering around things. It's way uglier, but it works for me. I mean, I can move from editing, adding several FMT prints around and run them in like less than a second. So it's way, way, way faster.
Yeah. The thing here is like the first time that you started, right? You will need to download all the modules and everything, and it's going to be quite slow. But once you have this set up, I would say that it's pretty much like, as you say, it's really fast. Like for example, in here, I can just start now the debug server, and this is just going to start the delve by the delve command that I showed you before, right? Which is this one. And then from here, when I basically hit the run thing here, you're going to see that in the let's see if it works right now or not. But this is just going to compile everything again, and you're going to see that it's going to create this debug bind, which is basically the same as the AWS operator, but I guess it's compiling with like different flags, something like that. And then you can start like just using these like breakpoints, and you can stop the AWS operator in any of these points.
Yeah, absolutely interesting.
The cool thing that I also like about this is that that I don't really care if like this whole thing goes down, right? Because I'm editing the code locally in the end, right? So I can do these commits and I can do whatever I need locally, and I know that I'm not going to lose it because the pod restarts or something bad is happening in the cluster. Right? Also in the README file here, I think I had some instructions on how to run the code server inside the cluster, but it's a little bit strange. So now you can see that the Delph has just started. Keep in mind that I think I need to debug something because this Delph binary is downloading all the modules again, and I think it's storing in a different place. But basically here you're going to see that now when I start it, right, this is already like I can basically like follow just the breaking points, and I can start looking at all the structure of the data that we have inside here. So this is sometimes cool when you want to see the data at any given point of time, right? Just like if it was locally. And here there can be some issues. Yeah, because I think this Docker Hub token is something that we introduced recently, and I just need to modify this, how we launch Delph. But basically, once you have this set up, you can just continue like launching it from here. And every time you hit this play button, it's going to build the whole thing again automatically. And this is it. The only thing that we need to, like few notes in here, we need to remember to Okteto down -v to revert the deployment once we finish, and also delete the persistent volumes. My personal experience is that developing locally with Beam or VS Code locally works better than deploying code server inside and basically running code server from the inside. The things that I don't like for now is that we need to modify the Okteto file YAML to select the branch that we are modifying. And I'm also thinking of creating something inside devctl that will basically modify this Okteto file on the fly, or maybe also update the Delph command from the deployment that we have defined inside the Helm chart. So we don't need to basically maintain this debug server file or this Okteto YAML and modify it depending on the case. Finally, you're going to see that Okteto has like enterprise product, whatever. We are just using the CLI, which allows us to synchronize to an existing cluster. And if you want to take a look, this Okteto YAML is already on master in the AWS operator, and we are just going to maybe continue improving it for this case. But I think it's could be pretty easy to set up in any of our repositories. Now, any questions? Not sure if we could be doing this multiple times in the same cluster. But could be that we could do this like with several operators at the same time. I'm not sure how these syncing ports are actually being mapped. locally.
But I guess the workflow when there are several different people working on the same operator will be that each team member creates a deployment for themselves
Exactly.
and then work on the deployment. Okay.
Yeah, like I don't multiple people working on it. I don't think there is any problem. And the only problem could be that if you want to start multiple Oktetos on the same laptop, because I don't know if the port mapping is done correctly in there.
That's a cool setup, especially for the remote debugger part. But when the volume is gone, you actually have to go through syncing from scratch again, right?
Yes.
Yeah, okay. Which is a bit slow.
This is why, like, if you know that you are done, right? This is when you actually need to delete the persistent volume.
Yes.
Otherwise, if you're in the middle of a session, just keep using the same one.
Okay. But can't you just compile a binary with the debug symbol in there and run this and run the remote debugger? So you don't have to sync the entire source files, because this is very expensive, I feel.
Well, I mean, the source files, you're going to see that it takes a minute, and once this is done, you don't even notice it.
Okay.
Because in the end, the synchronization with sync thing, it's like almost, I would say, instantly.
Okay. Well, if it's the binary, it's a couple of megabytes every time. So yeah, probably slower in the repetition. Okay. Nice.
I mean, the most expensive thing when you are doing remote compiling, I would say, is the first time that you download all the modules from Go,
Yeah.
which takes a while. What I wanted to try with installing the VS Code inside on the cluster was to see if we could share the session, and then multiple people could be working on the same, like each one with its own VS Code, modifying the same operator, right? Because sometimes you want to pair program and you want to modify something,
But you
and
could,
sharing.
Okay.
but you can do that through VS Code, right? You can do VS Code sharing, and then it's basically the same editor.
Exactly. But I wanted to see if I could do that, like set up everything inside the cluster, and then you just receive the link, and anyone that gets to that link is already can already modify it.
But it would be the same as sharing the VS Code, because you're literally on this other person's machine.
Exactly.
If you share with VS Code, so I don't think there would be a difference really.
Yeah, the thing is that to share the session, right? I could share the session from my laptop, but I would like to try sharing it from inside the cluster itself.
Okay. I see.
This way, like multiple people can pair program on inside the cluster itself, and I can just disconnect anytime, and it doesn't affect the other people.
Okay. Yeah, true.
But you need to be logged into Microsoft and GitHub and everything. And the VS Code server is not the Microsoft version, and it doesn't have the capabilities of sharing the session, so not doable.
Okay. Cool. So it would be cool if we would have like the steps you did in the video. Now, are they also in the README? I saw the Okteto file in the AWS operator README, but I didn't see the.
Yeah, I think so.
It's in there. Okay. Because it would be really cool if we could do something like devctl Okteto up or something, and it would just do all these things for us. So
yeah, this is what I was thinking on. And I was talking to the Okteto guys because I know them personally, and I think Jose also knows them, the people behind Okteto.
Not personally, no.
Okay. But then also in the Okteto file, we can put any environment variable, right? And that's going to be replaced on the fly with any environment variable that you have in your command line. So my thinking was to have like a generic Okteto file, and then the devctl would just set up the correct environment variables and fire everything up.
Yeah, I'm personally not a big fan of environment variables, but
Yeah.
it works. If it works, it works.
Yeah.
I'm not using this debugger, and for those who also don't want to start with something that not complicated, extended version, it was probably more logical way to start for me just to show how I do it, and then go with POW, because mine is like junior setup, and then there is this cool thing with POW does. So I just do build. Here I have version 8 something 6, and then yeah, I have shorter. By the way, do you see my screen, right?
Yeah.
Yeah, I have super small Okteto file, which just syncs this binary and runs it. And here I have a directly specified deployment name and namespace. Yeah, you probably need to patch the same thing POW does. Yeah, I already patched it, and then you just do Okteto up.
So you can see here in vol, the command is already starting the ADS operator. So you don't get this like shell, right?
Yeah, it directly starts operator. I just built. So it's syncing it, and yeah, it's just the smallest thing you can get. Yeah, and it's running. So that's the kind of initial setup you could get and start with it, because it's like doesn't require setting up Delve, because for me now starting with Delve, I need to start with how to actually use Delve, because I don't use it. So if you just want to start with binaries, that's also already an improvement which like reduces my workflow from like 10 minutes to 1 minute on every case.
And looking at like different alternatives to Okteto, right? Everything else that I've been looking for, it's like too complex, because it's like trying to replace also the build step and creating a Docker image, and you need to push it somewhere, and then it's like completely mess. And this feels like we're just hacking and uploading whatever we want, right? So I think it's also like give some freedom for you to do whatever you want.
It's at least, it's like it's some magic underneath, but it's at least clear magic what it does.
Yeah.